Fraction estimation. I can estimate fractions.
So 3 and 1. Factor 3 less than 1 fraction estimation. You can just say 3.1 of these. And estimating fractions is our I can statement. Hopefully that is something you can now do. Focus here is on the word estimate. I love, this is kind of our own made up definition, but an educated guess based on 2 things. 1, rounding, and 2, basic fact knowledge. Okay? So, using rounding and basic fact knowledge, we started estimating fractions. And when just giving a fraction, which live between, what 2 numbers do fractions live between, you guys?
0 and 1.
So when estimating fractions that live between 0 and 1, which is where all fractions live, you have 3 options for an answer. The options are
0, 1/2, or 1.
0, 1/2, or 1. Okay, so then when you got a problem like number 6a, it says estimate the value of each fraction, most of you, if not all of you, said, Mr. Podger, the answer is 0. 1/10 is closest to 0. That was all fine and dandy, but do we always care about the answer?
No.
We actually rarely ever care about the answer. We care about how you got the answer. So you have to prove it to me. The best way that I can think of to prove it is to go ahead and draw yourself a number line, which you all did. So we drew a number line, and we labeled the number line with 3 benchmarks, our 3 possible answers, 0, 1, and 1/2. Yes, no?
Yes.
And then from there, since we have to put this in terms of tenths, because the problem is 1/10, we labeled this 0 benchmark as 0 tenths. We labeled this 1 benchmark as 10 tenths, because 10 over 10 is 1, yes, no?
Yes.
And then your fraction for 1/2 is half of 10, which is 5 tenths. From there, you added your marks. 1/10, 2/10, 3/10, 4/10. We already have 5 tenths. 6 tenths, 7 tenths, 8 tenths, 9 tenths. Yes, no?
Yes.
You took your problem 1/10 and you graphed it right there. And 1/10 is closest to what number? 0, 1/2, or 1?
0.
0. So that's where we came up with the answer 0 that you boxed your answer. B, you can take a look at that one on your own. We got 1/2. C was a little trickier. I'm not going to run through the whole process, but we graphed 3/12 right here. And 3/12 was 1, 2, 3 steps away from 1/2. Then it was 1, 2, 3 steps away from 0. Yeah, we said the answer was 1/2. Can someone raise your hand and say why we went with 1/2? Alice?
3 or above.
Because if it's in the middle, not 3 or above, if it's in the middle, we give it a shove, just like the number 5. 5 and above, give it a shove. And then the other trick that we ran across was letter D, in which we had a denominator of 9. Okay, so we had 0/9 right here, we had 9/9 right here, and then we said, well, this is actually really 4.59. Yes, no?
Yes.
Is it really legal to do a decimal within a fraction?
No.
Not really, but we're kind of bending the rules for this one. You guys found 7/9 was right here, which is closer to 1. The other thing you could do is what? Instead of graphing 7/9, you could do what, Abby?
Find an equivalent fraction.
So an equivalent fraction for 7/9 is what, Abby?
14/18.
So if you multiply both by 2, the top and the bottom by 2, you get 14/18. And you all know that anytime you have an odd number and you multiply it by 2, it's going to turn into
Even number.
an even product, right? So we just got an equivalent fraction of 14/18. And then you could have went ahead and graphed 14/18 using the number line method that you just learned about, right? A couple of you said you like doing that better than just cheating and bending the rules and writing 4.59. Mixed number estimation, there are 2 answers. What are the 2 possible answers with mixed number estimation? Someone raise your hand. Sedona?
The given number or the number above that.
The given number or the number above it. So for 3 2/3, we said that the estimate is 4 because 2 is what compared to 3, Sedona?
It's greater. Or it's less than
2 is less than 3, but why did it tell us to push this number to 4?
because half of 3 is 1.5 and 3 is
Cool, so if your numerator is at least half of the denominator or more, you give it a shove. Okay, and then number 9, 26 and 1/9 just stays 26 because 1 is nowhere near half of 9. And then number 4, I'm just going to be brief on number 4. It is taking the whole idea that we just went through and putting it all together. So Nathan did a wonderful job on this one of graphing 7/8 using this graph right here and graphing 1/12 using this graph right here to prove that 7/8 plus 1/12 is 1. And then down below here, we have a mixed number and a fraction. Do you need to show any work for the mixed number, you guys?
No.
No, I'm not going to make you. So the only work that we showed for this one was for 16/19, which is that fraction. Questions, comments?